to class of physics. This is second video lecture. In first video lecture I discussed the syllabus of paper 2 and also started the unit electronics. In that I have given some introduction about oscillators as well as multivibrators. And one type of the multivibrator is astable multivibrator. Here I am going to discuss. Let's see what is astable multivibrator and why we call it as astable multivibrator. The circuit is not stable in either state. It continuously switches from one state to other state. That's we call it as astable multivibrator. It functions as relaxation oscillator. An astable multivibrator is one type of free running multivibrator. This free running multivibrator is because of there is no requirement of any input triggering pulses. Itself it is providing the output. That's why we call it as free running multivibrator. The output of an astable multivibrator is square wave form. By varying the RC time constant, the coupling circuit, the square pulses of any desired width can be obtained. By changing the values of resistors and capacitor, the operating frequency can be changed. The frequency of this oscillation is completely depending on the capacitor and resistor used in this circuit. And the main working component is here the transistor. The transistor is worked as switched. Okay, this is the circuit diagram of astable multivibrator. Here we are using RC1, R1, R2, RC2 are the resistors, C1, C2 are the capacitors, Q1, Q2 are the transistors. And this is the transistor diagram, how it is working. If you are providing the sufficient voltage to the base terminal that is greater than 0.7 volt, now it starts conducting. That means the collector and emitter will be short circuited, then it will conduct the current. That will say that it is in saturation state. In other words, if you provide the less than 0.7 volt to the base terminal, then it will be in cutoff region. That means there is no conduction of any current through this terminal collector and emitter. So that we call it as open circuit or cutoff regions. Okay, so this is the basic working of transistor in the astable multivibrators. In the above diagram, we can find the two transistors which are wired as switch. Those two transistors are Q1 and Q2. When a transistor is on, its collector and emitter acts as a short circuit. But when it is off, they act as open circuit. In the above circuit, when the transistor is on off state, its collector will have the voltage VCC, and when it is on state, it will be grounded. When one transistor is on, the other will be off. The off time of the transistor is determined by RC time constant. When the circuit is switched on, the one of the transistor will be more conducting than the other due to imbalance in the circuit or difference in the parameter of the transistor. Gradually the more conducting transistor will be driven to saturation and a less conducting transistor will drive into cutoff. This is the circuit design and how it is conducting the current. Let's see the working of this astable multivibrator in brief. When the circuit is first powered up, neither transistor is on. That means when you are providing the voltage VCC to the circuit, neither transistor is on. Both VB1 and VB2 rises by base resistor R1 and R2 respectively. Here the base voltage is rises from resistor R1 and R2. So like this R1 and R2. These two will provide the base voltage to the transistor Q1 and Q2 in opposite directions. The transistor will conduct faster than the other due to circuit imbalance. We cannot say which transistor will turn on first. So for our analysis purpose, we can assume that Q1 will conduct first, Q2 will be off. When Q1 is conducting, Q2 will be off. That means now the Q2 transistor will be in cutoff regions. Assume that like this. And let's switch on. Now since Q1 conducts, Q2 is off. VC1 is 0, VC2 is VCC. So here VC1 is 0 because this terminal is grounded. For that the voltage is here, it is 0, but the at VC is provides 1 because there is no ground, there is a break in the circuit. For that the maximum voltage is appeared at C2 only. Next step, due to high voltage at VC2, the capacitor C2 will be charged by RC2. So that is low resistance path because RC2 is greater than R2. C1, which was charged earlier and cannot hold the charge for indefinite time period. C1 starts charging by R1. Time taken to discharge C1 is R1 C1. Here now the capacitor C2 is charging through the resistor RC2 in this way, and the capacitor C1 is discharges in this way. Okay. So this is charging and this is discharging. So in these conditions the voltage at VC1 is 0 volt and voltage at VC2 is the maximum voltage VCC, and the time of discharging is given by R1 C1. When C2 is fully charged, the left plate of capacitor C2 will be negative VCC, which switch off the C1 Q1. When C1 is fully discharged, then left plate of the C1 will be at positive, which switch on the state Q2. In next state, what happens? This terminal becomes negative. When it becomes negative, the base of the transistor 1 will be provided by negative voltage, then it will go to the cutoff region, and the right side of the capacitor C1 will become positive, that is greater than 0.7 voltage. Then what happens? The base of the transistor Q2 will be getting more than 0.7 volt. In that conditions the Q2 will be starts conducting. So that is the state 2. So like that the states are continuously changing from low state to VCC. Okay. When VB2 reaches the circuit enters in the state 1 again, and the procedure will repeats. So this is the working of transistors, and the output waveforms are like this. When the transistor is not conducting, first take when transistor is conducting, the output of that collector will be 0. Okay. When it's go to cutoff region, the output of that collector will be at higher state, that is VCC, and when again it comes back to its saturation state, the output of the collector will be at 0 state. So like that the state will be continuously changing, will provide the square waveforms, and the time period of this square waveform will be calculated by the RC time constants. The time for which either transistors remain on or off is given by on time of for Q1 or off time for Q2, that is 0.6941 R1 C1. Similarly, off time for transistor 1 or on time of transistor 2 is given by 0.694 R2 C2. The total time period of the square wave is given by T1 plus T2, that is equal to 0.694 R1 C1 plus R2 C2. If you consider the R1 and R2 are of the same resistance value, that is equal to R, and the capacitance are of the same values, that is equal to C, then the time period will become 1.4 R into C. The frequency is reciprocal of time period, that is F equal to 1 by T, that is equal to 1 by 1.4 into RC. So this is about Astable multivibrator and its working. In next class I am going to start a monostable multivibrators as well as bistable multivibrators. Okay. Now take the assignment questions. The question is, what is a stable multivibrator and explain its operations. Okay. Please submit the assignment in the same day only. Thank you.